Yes.
Okay. So let's check answer with you. Maximum allowable mud weight.
12.5.
Yes. Must be before kick.
What? Sorry, I didn't understood.
Second one must be before kick. Must
1175.
initial must
1175.
150.
150. Okay, 1150. Okay. Strokes from surface.
Sorry. One thing about the MASP.
Yeah.
The MASP and the maximum allowed mud density. So
Maximum.
the maximum mud.
Yeah.
Maximum mud weight allowed mud density is 12.55 something. So we round down.
Yeah, 12.5 is the answer.
Okay. Then we calculate from this one the MASP.
Yes.
And we'll round down. Okay, again.
Yes.
So like this, we are going so far from the real MASP.
No.
Yeah, because it's the maximum allowed, the density is already ramped down, and this one also ramped down.
Yeah. So the MASP now has been decreased, right? So you are in safe zone. You are in safe zone.
Yeah, but same we need the maximum.
Yeah.
If
So
there is a big amount of gas.
Yeah, if the actual maximum is 10 and you make it 9, so it's okay, you are in safe zone, not to reach the maximum. Okay. So the answer will be 1150. Okay.
Yeah.
Number 3, strokes from surface to bed.
1731.
1725. Okay.
Yeah, I got 1725 also.
1725, it's okay. 1724, it's okay. 1723, it's okay. We have range as mentioned. Okay, 1725 is okay. Kill mud weight.
11.
10.9.
No, we need to round up, so it will be 11. Yeah, 11. Okay, so kill mud weight need to be rounded up. So 10.9 round up 11.
Yeah, I got like 10.93 and then I will take that to 11.
Yes, kill mud weight, you need to round up to add more overbalance. Okay. ICP, initial circulating pressure.
1275.
Yes.
Yes, I got the same.
Okay. FCP, final circulating pressure.
760.
764.
No.
65.
Yes.
No,
75. 65.
So we have this one, you have to round down.
Round up, yes, to have overbalance.
How much guys you took?
765. But I think it may be wrong with you. You do wrong calculation of kill mud weight. What's your answer for FCB?
Oh yeah. No, that's fine. I type it wrong. Yeah, it's okay. I see my wrong here.
Okay, so guys, for the second page of kill sheet, kill mud weight round up, FCB round up, and pressure drop per 100 stroke round down. Okay.
FCP up and
kill mud weight up.
Okay.
And pressure drop down.
Yeah. So this one is 500, 10, 2500 divided by 725.
Okay.
So the pressure 29. I find the 29 PSI.
Is the pressure for what?
The for each stroke, 100 stroke counter.
Okay, but here,
decrease.
Yes, but here he asking for pressure drop 1/10. So you need to take ICB minus FCB over 10. He didn't ask for 100. He may ask, but he now.
Where?
Yeah, second page.
I didn't check the second page at all.
Yeah, every kill sheet has some question. Same questions.
Me too.
Yeah, eight questions. Okay, so you
I feel it all the Q sheet.
No. So this may take much time from you. All the time he asking only for strokes from surface to bed. So you need to calculate the real string volume only. Okay, not to calculate time or anything else. So
That means 51. That's it.
yeah, it will be 51. Yes. So what about mass after kill? After well is killed, mass you calculated?
No.
Okay.
No, really no.
Okay, so it will be maximum allowable mod
1.5
weight.
multiplied by 0.025 multiplied by 690.
690. Yes. Okay. Good job, guys. So as mentioned before, we have 4 kill sheets. One of them will come in the exam with the same number. Okay, same sequence of questions. So we need to practice them more and more carefully, so it takes no time in the exam. Okay. Okay. So now we're gonna talk about well control methods. So let's share with you the whiteboard. Okay, let's upload a new one. Okay, so now guys, we're gonna talk about the well killing method or well control method. It divided mainly into conventional or routine. Conventional means you are on bottom, and unconventional means you are off bottom. Okay, so conventional methods like the driller method and wait and wait. And here unconventional like the volumetric method. So the driller method, guys, have 2 main circulation. First, circulation, and second, circulation. Here, wait and wait, only one single circulation. Okay, so let's talk in brief about them. For the driller method, first circulation, this one. We have our well like this, drill pipe. Okay, and the well is filled with original mud weight. While drilling, we have a kick. So we shut in our well and we need to start killing the well using the driller method. So starting by the first circulation. So the purpose of the first circulation of the driller method is to make displacement for this influx out from the well. Okay, out from the well by pumping original mud weight. So again, the purpose of the first circulation is to make displacement for the influx, make displacement for this influx out from the well by pumping the original mud weight. Once the influx out from the well, and the well now is completely filled with the original mud weight, so we successfully conducted the first circulation of the driller method. Okay, so briefly for the second circulation, now we have our well like this, our drill pipe, the well is closed, and once conducting the first circulation, so the well now is completely filled with the original mud weight, no influx inside the well. So to kill the well, we need to pump kill mud weight. So here, let's go ahead, start pumping kill mud weight inside the well. Once the kill mud filled the well and making displacement for the original mud weight. Now the second circulation has been finished, okay, and you're gonna check for pressure. So you're gonna find shot in drill pipe pressure equal shot in casing pressure equal 0. Okay, here once finished the first circulation, gonna find shot in drill pipe pressure equal shot in casing pressure equal the original value of shot in drill pipe pressure. Okay, so again, guys, the first circulation purpose is to make displacement for the influx out from the well by pumping the original mud weight. Once finished successfully, we're gonna find shot in drill pipe pressure equal shot in casing pressure equal the original value of shot in drill pipe. Okay, for the second circulation, you're gonna pump kill mud weight, making displacement for the original mud weight. Okay, so once the well is completely filled with the kill mud, you're gonna check for pressure, shot in drill pipe pressure equal shot in casing pressure equal 0. Okay, so what about the weight and weight method? Now we have our well like this, drill pipe, the well is closed, the well was filled with the original mud weight like this. Okay, we have some influx inside the well. So the purpose of the weight and weight is to pump kill mud weight, okay, at one single circulation. Pump kill mud weight here inside the well at one single circulation, making a displacement for the influx and displacement for the original mud weight at the same time. Okay, so weight and weight, only one single circulation, no two circulation like driller, one single circulation, make displacement for the influx, make displacement for the original mud weight, okay, and now your well is killed. But driller, you need first to displace the influx out from the well, then kill the well by pumping kill mud weight. And weight and weight, in one single circulation, you pump kill mud, making displacement for the influx, making displacement for the original mud weight. Okay, for volumetric method, you are of bottom or no pipe inside the well. For example, like this, no pipe inside the well. You close the BOP. Okay. You have influx inside the well like this. Okay. And here is your original mud weight. So the sequence or the mechanism of volumetric method not included or not involved in our course, but we're gonna discuss briefly about it. The purpose is to allow this influx to reach the surface, okay, by a mechanism, okay, allow this influx to expand, okay, by bleeding some mud, then allow it to expand, bleeding some mud, allow it to expand, bleeding some mud. We're gonna make these steps while keeping bottom hole pressure. So the first of the volumetric method is to give yourself 100 psi as a safety margin, okay? Then give another 100 psi as a working margin, okay? Then start to bleed some mud, let gas expand, okay? So casing pressure gonna be increased. Then bleed some mud, so casing pressure decrease, then keep casing pressure increase, and make this sequence of operation more and more, taking much time till the influx or the gas reaching to the surface. Once the influx or the gas reaching to the surface here, okay, so now volumetric method has been done, and we're gonna start lubricate and bleed method as we're gonna see later in our presentation. So now let's go ahead talking in details about our well control methods. Okay, so here is our well, starting by driller method, first circulation. Here is our well, like this, drill pipe. Here is our drill pipe. The well is closed. The well was filled with original mud, like this, while having some influx inside the well, like this. Okay, so let's start with the driller method. First thing here is start pump slowly, 5 SPM by 5 SPM, while holding. Okay, let's start pump slowly 5 SPM by 5 SPM till reaching kill rate, for example 30 SPM, while holding casing pressure constant. That's called correct startup procedure. Okay, so anytime you need to start your killing operation, you need to run pump slowly 5 by 5 till reaching kill rate, okay, while holding casing pressure constant. Okay, so now once reaching kill rate 30 SPM, drill pipe gauge reads ICP value equal shot in drill pipe pressure plus SCR pressure. So now here, once reaching kill rate, now drill pipe gauge read ICP value. Okay, so let's have a look now. On the two sides, we have drill pipe side and we have annulus side. Drill pipe side have only one fluid, the original mud, but annulus side have two fluids, influx and original mud. So all the time we need to keep the one phase fluid pressure, okay, one phase fluid pressure. So now after drill pipe gauge read ICP, let's say continue pumping, okay, original mud, holding drill pipe pressure constant at ICP till the influx out from the well. Okay, so we're gonna pump here original mud weight till the influx is completely out from the well, and now the well is completely filled with the original mud. Okay, so the next step, yeah.
Sorry, the second step, drill pipe gauge, read ICP. ICP.
Once reaching kill rate 30 SPM, yes.
Okay, this the ICP is not casing is not drill pipe shut-in pressure.
No, ICP equal shut-in drill pipe plus SCR.
Is the first that means it's the first circulation pressure.
Yeah. Here SCR pressure is the pump pressure plus shut-in drill pipe pressure. Any problem with this point?
No, that I thought that the pump pressure should be equal the casing shut-in pressure plus the SCR pressure.
Again, what you want?
I thought that the pump pressure read the previous shut-in drill pipe pressure plus
No,
the
no.
SCR pressure.
ICP equal shut-in drill pipe pressure plus SCR pressure. So what is the problem? We just calculated in our cal sheet, right?
Yeah.
Okay, so you have a problem with this calculation?
No.
Okay, so here once reaching kill rate, for example, 30 SPM, okay, drill pipe gauge will reach ICP value, shut-in drill pipe plus SCR pressure or pump pressure, okay? Okay. Hey, okay or not to complete?
Okay.
Okay. Okay, then continue pumping the original mud, holding drill pipe pressure constant at ICP till influx out from the well. Now shut down, pump slowly, 5 SPM by 5 SPM, while closing choke completely. And last thing, a check for pressure. Okay, after successfully conducting the first circulation of the drill method, you're gonna find shut-in drill pipe pressure equal shut-in casing pressure equal the original value of shut-in drill pipe pressure. So for example, if we have from the beginning shut-in drill pipe pressure is 350, shut-in casing pressure equal 400. So after conducting successfully the driller method for circulation, we're gonna find shut-in drill pipe pressure equal shut-in casing pressure equal 350. Okay, so what will happen if we found shut-in drill pipe equal shut-in casing, but instead of 350 equal 450? What is the problem, guys?
So we are over 100.
Yes.
Say over.
Yeah, so we may have something called trapped pressure. Trapped pressure. So how to check for trapped pressure? Start bleeding. Bleeding 50 psi. 50 psi. If no pressure build up, so that's trapped pressure. If there is pressure build up again to 450 and more, so there is influx inside the well. Secondary influx or further influx. Okay. So what will happen if we found shut-in drill pipe pressure, for example, shut-in drill pipe pressure equal 370 and shut-in casing pressure equal for example 430. So what is the problem?
We still have another influx.
Yes. Okay. So now let's go ahead with the driller method second circulation. Okay, for driller method, second circulation. Okay, we're gonna start with the same thing here. Let's clear this one. Same thing. Start pump slowly, 5 SPM by 5 SPM till reaching kill rate 30 SPM while holding casing pressure constant. And this one is called correct startup procedure. Second thing, once reaching kill rate, drill pipe gauge reads ICP value. ICP equal what? Equal shut-in drill pipe pressure plus SCR pressure or pump pressure. Okay, so now we're gonna pump from here, kill mud inside the well. Okay, so once the drill pipe gauge reads ICP, we're gonna look to our well. In the drill pipe side, we have two fluids, kill mud and original mud. In the annulus, we have only one fluid. So we need to keep the annulus pressure, the casing pressure constant. Okay. So here's the second step is continue pumping. Continue pumping kill mud, keeping casing the pressure constant till kill mud reached the bed. Okay, so once reaching kill rate, we having here on drill pipe gauge ICP value, gonna pump kill mud inside the drill pipe till kill mud reaching to the bed. Once kill mud reaching to the bed, now drill pipe gauge reads FCB value. That's equal kill mud over current mud, kill mud weight over current mud weight times SCR pressure, and round up for this value. So now drill pipe gauge reads FCB. Okay, so what is the next step? Look here, we have on the drill pipe side only one fluid, but in the annulus, we're gonna have kill mud and original mud. So the next step is continue pumping keeping drill pipe pressure constant at FCB till kill mud reach surface. Once kill mud reaches to the surface, now second circulation of the driller method has been conducted successfully. Then you need to shut down pumps. Okay, close the choke completely. And last thing is to check for pressure. After successfully conducted that, you're gonna find here shut-in drill pipe pressure equal shut-in casing pressure equal 0. Same thing if we found shut-in drill pipe equal shut-in casing, but instead of 0, 100. So we may have trapped pressure. So how to check for trapped pressure? By what? By bleeding 50 psi. If bleeding 50 psi and no pressure build up, so it's okay, it's trapped pressure. If pressure build up again, so kill mud may be not sufficient enough. Okay. Another case, if we found, for example, shut-in drill pipe pressure here, shut-in drill pipe pressure equal 0, but casing pressure, shut-in casing pressure equal value, for example, 70 psi. This means that the kill mud, for example, not reaching to the surface. Yeah, still not reaching to the surface. So this area still having original mud, and this caused a pressure, back pressure on the casing pressure. Okay, so once shut-in drill pipe 0, this means that kill mud already filled the drill pipe, but casing pressure has a value. This means that kill mud didn't reach it to the surface yet. Okay, that's for driller method weight and weight. Let's have a look on the weight and weight method. Okay, so now weight and weight method, also called engineer the method because it has some calculations. Okay, so here is our well, the drill pipe. The well is closed. The well is lined up to the mud pump. Okay. Okay, the well was filled with original mud, like this, while having some influx inside the well. So as mentioned, the weight and weight method is to make displacement for the original mud and for the influx at one single circulation. So here, to start weight and weight method, same thing. Start pump slowly, 5 SPM by 5 SPM, while or till reaching kill rate 30 SPM, for example, while holding casing pressure constant. Okay, this is called correct startup procedure. Once reaching kill rate, drill pipe gauge reads the ICP value. Okay, reads the ICP value. Okay, so now here we pumping kill mud inside the pipe. Once reaching kill rate, now the drill pipe gauge reads ICP value. Okay. What else? Once surface line volume has been pumped, make 0 strokes. Okay, the 0 stroke count. So once we pumping the capacity of surface line volume, we need to make 0 strokes. Why? Because we're gonna follow step down table. You're gonna see now. Okay. Okay. So now we have some basic calculation you already know. Let's mention again for them. Here, ICP equal shot and drill pipe pressure plus SCR pressure. FCP equal kill mud over current mud times SCR pressure and round up. And we have delta P pressure drop per 100 stroke equal ICP minus FCP over drill string volume in strokes, okay, times 100 and round up. Okay, so let's say here we having our ICP is 900, and let's say here FCP is about 400, and our drill string volume is 800 stroke. Okay, and let's say, yeah, okay, it's okay. So now, guys, after making this calculation, you're gonna have a look on the two sides, drill pipe side and the annulus side. Annulus side has two fluids, influx and original mud. The drill pipe side gonna have two fluids, kill mud just enter to the well and the original mud. Okay, so no one phase fluid we can keep as pressure constant. So here we need to, second step, continue pumping following step down table or step down graph. Step down table or drill pipe pressure schedule, step down schedule, following step down table for drill pipe pressure. Okay, so let's make our calculations for delta P. Let's say our delta P, okay, not to calculate, our delta P is 50 psi after roundup. Okay, so now here, let's make our step down table. Here is number of strokes. And here is drill pipe pressure. Okay, so number of strokes we having here, 0 stroke, 100, 200, 300, till reaching the full capacity of the drill string, 800 strokes. We make 0 strokes, okay, once pumping the surface line capacity, and we having the pressure ICP on the drill pipe gauge. Now, at 0 stroke, we having ICP value. Let's say equal, as mentioned, 900 PSI. And by pumping 100 stroke, the pressure dropped by 50 PSI, 50 PSI per 100 stroke. Now we having here, after pumping 100, to be 850. Then another 100 to be 800. Another 100, 750. Okay, till pumping the whole capacity of the drill string. So at 800 stroke here, once the kill mud reaching to the bed, okay, now we're having FCP value equal to 400 PSI. Okay, that's called step down table or step down graph. You need to continue pumping following the step down table for drill pipe pressure. Okay, so what is the next step? Once kill mud reach bed, drill pipe reads FCP. Okay, continue pumping, holding drill pipe pressure constant at FCP till kill mud reach surface. Okay, then shut down, pump, close, chuck, and check for pressure. After successfully conducting the wet and weight, suppose that shut-in drill pipe pressure equal shut-in casing pressure equal 0. Same thing, if we found, for example, here, shut-in drill pipe pressure equal shut-in casing, but instead of 0, 100, so we need to check for trap pressure. Okay, so what will happen if we found shut-in drill pipe pressure? Shut-in drill pipe pressure equal 0, but shut-in casing pressure still have a value, say 100 PSI. So here, what is the problem, guys? We have two case scenarios. First thing, kill mud not reaching to the surface, right? Kill mud doesn't reach to the surface. Why? Why doesn't reach to the surface?
Dual geometry or volume, open volume.
No, we may don't make re-zero for stroke counter. Okay, so if we ignore to re-zero stroke counter, or if we take the surface line volume into our calculation, so here at 0 stroke you have ICP. Once pumping the first 100 stroke, the surface line volume, say the surface line volume is 100 stroke. So after pumping 100 stroke, you're gonna keep 850. After 200 stroke, 800. So here you didn't take the 100 stroke of surface line volume into your calculation. So after pumping the total calculated volume of the kill mud will reach to this specific point. Still here, 100 stroke didn't reaching to the surface before reaching to the surface. Where this 100 stroke come from? Because you pumping the surface line volume and didn't make 0 for stroke counter. Okay, so you.
But this one,
yeah.
This one you can control it, yeah. But if the well, wash out or something, this one you cannot control it. So
yes.
Also, you can maybe you have more annular volume.
Yes. If you have error in your calculation or wash out in the formation, yes. Okay, but you can control the situation or go ahead with keep pumping kill mud till kill mud reaching to the bed. Now check for pressure again. You're gonna find 0 on both gauges. Okay. Okay. Now let's back again to our presentation. Well control methods, starting by the driller method, first circulation. If you look here, we having some influx inside the well, okay, and we need to circulate or kill the well by the driller method. So first circulation is to keep pumping the original mud weight, the white one here, to make displacement for this influx out from the well. Starting with shot-in drill pipe 530, shot-in casing is about 700 psi. So here, gonna pump. First thing reaching here 30 SPM, so drill pipe gauge reads ICP value. Okay. Okay. Keep pumping the original mud weight, making the displacement here for the influx. If you look here, the casing show pressure will be maximum when the top of the influx reaching here. So here, once the influx reaching the top, here maximum casing show pressure. Okay. We're gonna complete pumping, keeping the drill pipe pressure constant at ICP. Okay, till the influx now at the top. Okay, now the influx is out, keeping ICP value. Okay, once the influx is out from the well, so casing pressure will be equal to the original shut-in drill pipe pressure. Once we shut down the pump, okay, so shut-in drill pipe pressure gonna shut down equal shut-in casing pressure. Both of them equal 530. Okay, 530, the original value of shut-in drill pipe. But look here, once we are in the open hole, our eyes on the mask. Okay, not to allow casing pressure to reach the mask, not to frag the formation. Once you are inside the casing string, so it's okay. Okay, no caving of the mask. Okay, now to talk about the second circulation of the driller method. Look here, the well is completely filled with the original mud. Okay, the pump is running rate. So here we have ICP. Now we're gonna pump kill mud. We having two fluids here and the drill pipe. So we need to keep casing pressure constant at 530 till kill mud reaching to the bed. Now kill mud reaching to the bed. So drill pipe gauge reads FCP value. So we need to keep FCP value constant till kill mud reaching to surface. Once kill mud reaching to the surface, casing pressure equals 0. Once we shut down pump, so drill pipe pressure also gonna equal 0. So coming to talk about weight and weight method. Here we have influx inside the well. So two fluids here. And the drill pipe, once we pumping kill mud, we have two fluids. So no one phase side to keep its pressure constant. So we're gonna follow pressure schedule, step down pressure schedule. Okay. So once pumping kill mud, drill pipe pressure gonna increase till reaching the final circulating pressure 692. Look here. Drill pipe pressure decrease till kill mud reaching to the bed. Now we having FCP value. So we're gonna keep the FCP value constant on the drill pipe gauge till kill mud reaching to the surface. And same thing, as long as the influx in the open hole, we need to keep eyes focusing on the mask and casing pressure, not to reach the mask and the frag formation. Now kill mud reaching the surface, so casing pressure equal 0. And once shut down the pump, so you're gonna find your drill pipe gauge equal 0 also. Okay, so during killing the well, guys, and circulating the influx out from the well, we may face some challenges or some problems. Like what? Like this problem: shock washout, shock plugging, hole in the string, loss circulation, nozzle blown out, nozzle plug, or pump failure. So your first action, if you face any of these problems, is to secure the well, shut in the well, and evaluate or assess the situation, then take proper action. So here, let's know how to identify these problems. First thing, if we have shock washout, so you're gonna find sudden decrease in drill pipe, then following after lag time, drill pipe pressure decrease. So how much the lagging time between the change in casing and drill pipe? If we have our well like this, and the choke is here, so once open or close the choke, open or close the choke, the casing pressure immediately changes. Immediate change, okay? Then drill pipe gauge here, drill pipe gauge have lagging time. After some time, drill pipe have the same change, okay? So what is the lag time? How much lag time between the change in casing and drill pipe? Anyone know?
1 second, 4,000 feet.
Yes, right. So if our well here is 5,000 feet, so how much time between casing change and drill pipe pressure change?
10 seconds.
How much?
10 seconds.
10 seconds, right. 5 seconds down and 5 seconds up in the drill pipe. Okay, right. Okay, if we have a choke plugging, so we're gonna find sudden jump or sudden increase in casing pressure, then after lag time followed by drill pipe pressure increase. If we have hole in the string, so only drill pipe pressure affected, decrease, and all parameters stay the same. If lost circulation, so you're gonna notice drill pipe pressure decrease, casing decrease, bottom hole pressure decrease, and bed level also decrease. Okay, and this one identifies lost circulation.
Sorry, what does it mean hole in string?
Washout in the string, hole in string.
Washout. Okay.
Yeah. Then if we have here one nozzle blown out, so your drill pipe pressure decreased, but casing not changed, PHP not changed, and bed level also not changed. If we have nozzle plugged, so sudden jump in drill pipe pressure, all parameters stay constant. If we have pump failure, so you're gonna find your SPM is 0, pump rate is 0, then drill pipe pressure decrease, casing decrease, bottom hole decrease, but bed level is stay the same. Okay.
Sorry, about the washout. If we have washout.
Washout in choke or pipe?
Washout in the pipe.
Okay.
So the bottom hole pressure will decrease, eh?
Decrease? No, not affected. Only drill pipe pressure decrease.
No, because the friction loss is we have different friction loss now.
Friction loss in the annulus or the drill pipe?
In the annulus and in the drill pipe, both.
Yes, but not affected too much. You know, not affected too much due to partial washout in the drill pipe. So you can't continue
because the mud is not reaching the bed, so it's passing. I don't know.
Yeah, if for example, if here we're having our drill pipe and there is a washout here or hole in the pipe, so there is, yeah, for sure there is communication from this point, but not affected the bottom hole pressure too much. Yeah, nearly constant.
In reality, in MPD, we are taking that is affected, but in well control here, I saw they don't take care about the friction loss even in weight and weight.
Yeah.
I saw that.
Yes, you're right. We ignoring somehow the friction loss here in this point. Okay. So now to talk about the volumetric method. Volumetric method not involved in our course in details. Okay, it requires some time, okay, much time to conduct it successfully. So first thing is to talk about the cases we're gonna use volumetric method. We have some cases. First thing, if our pipe is off bottom, or if we can't able to make circulation. So for example, the drill string is plugged or bed is completely plugged. The drill string is completely out from the well, washout in the drill string, okay? Or cut in the drill string. The drill string has been cut and left in the hole, so we need to remove the gas first, then start fishing operation. If we have equipment failure like pumps or motors. So what is the volumetric method itself? Volumetric method, if we have here, as mentioned before, if we are off bottom or we have plugging and we can't able to get blow influx and circulate it out. So what is the situation is to use volumetric method. So volumetric method is to allow gas to expand till reaching the surface by bleeding amount of mud from the choke by holding bottom hole pressure constant. Okay, so the first thing you're gonna make is to allow gas to migrate. So you have now 100 psi additional. Okay, you keep it as safety margin, then allow it to have another 100 psi as working margin. Then you're gonna start bleeding amount of the mud. Okay, so now gas expands and casing pressure started to increase. Then bleeding another amount of mud. Then casing pressure started to increase. Okay, and still making this operation more and more till the gas now reaching to the surface. This volumetric method take much time to be conducted successfully. Okay, then here you need to keep bottom hole pressure all the time constant, okay, or nearly constant by controlling drill pipe pressure if exists. Here, casing pressure allow to increase to compensate for the mud bleed. Once you're bleeding mud, casing pressure starts to increase to keep your bottom hole pressure constant. So here, casing pressure allowed to increase to compensate for mud bleed from the well till gas at the surface. Then we're gonna start lubricate and bleed method. So what about lubricate and bleed method? If you look here, we have no pipe inside the well and we allow the gas to reach to the surface. So lubricate and bleed is a closed loop or a closed system. So we're gonna bleeding some gas from here from the choke, and at the same time we pumping kill mud. The same sequence we make in volumetric method by bleeding, okay, bleeding 100 psi equivalent to the mud volume, and let casing the pressure increase by 100 psi and make this step more times till the gas reaches to the surface. Here is vice versa. Start pumping here kill mud inside the well, okay, allowing the bottom hole pressure to have 100 additional psi, then remove gas equivalent to this 100 psi. Then put another 100 from kill mud inside the well, then making the remove. Make this step more and more till the influx is completely out from the well and the well is being killed. Okay, so kill mud now is completely filled the well. This method consists in circulating new mud through the kill line with return to the choke line in a closed system with control of the volume of the tank while percentage of gas exit is separated. The volume of the gas that exits is replaced in the hole with new mud, the kill mud. There is another method called bullhead method, and this one to be used for in well intervention jobs, and especially if there is toxic gas like H2S. Bullheading is to pumping into a shut-in well to force formation fluids back again into the formation without cause any fracturing. This way is used especially with toxic gas like H2S. For stripping operation, guys, if we are, for example, making the stripping out from the well, then we have influx and we need to make stripping operation to get below the influx to circulate it out from the well. So stripping operation is to run the pipe into a shut-in well, okay, into a shut-in well to get the drill string below the influx and circulate it out. So how to make a stripping operation? First thing, for example, if we are pulling out of the well, then we have influx, okay? So first thing is to, as mentioned at the first or at the earlier of the day, first thing, we have a flow, okay? So we need to install drill pipe safety valve or full opening safety valve in open position, okay? Open position, then close it by a wrench. Now, the safety valve or for opening safety valve is closed, okay? Then install IPOP in open position, okay? Then remove the screw okay, locking screw. So now the IPOP in closed position. Okay, now IPOP in closed position and full opening safety valve in closed position. Back again and open the safety valve. So now the lineup, we have IPOP in closed position, drill pipe safety valve in open position. Okay, then we can go ahead and make our stripping operation. Stripping operation only be conducted from annular or fixed. From annular or fixed to fixed RAM. So we can make it from annular to fixed or from fixed RAM to fixed RAM, but we can't be able to make it from variable or RAM. Okay, so if our POP stack is annular, then here variable, then shear blind, then here fixed RAM. So we can only make stripping from annular to fixed, not from variable to fixed. If we have here fixed, so we have two options to make it from fixed RAM to fixed RAM or from annular to fixed RAM. Okay. While stripping operation, you need to fill the string every stance and bleed off close end as you run in the well. Okay, so you need to bleed here close end displacement. Okay, so fill from the surface, fill up from the surface every stance and bleed off close end displacement. If you have here, for example, if we have here some gas or some influx with height h small, okay, once you strip into this influx, okay, so its height gonna be increased. So once the height increase, so reduction in hydrostatic pressure will be increased. So casing pressure here allowed to increase. Casing pressure allowed to increase. If casing, so here casing pressure increase while stripped into gas bubble. If you keep it constant means you open the choke to decrease the casing to the original value. So now PHP or bottom hole pressure will decrease. Okay. So once you strip into a gas bubble like this one, okay, here we having h small height of the influx. Once stripping, so the height of the influx gets larger. So here casing pressure increase. If you keep it constant to this value, so you're gonna open the choke. Open a choke means you make reduction for bottom hole pressure. Okay, so you're gonna have further influx. Now to talk about formation ballooning. If you look here to this figure, once pump is on, so we have APL effect. Okay, so you may apply more overbalance. So some fluids will go into the pore space. Okay, your bottom hole pressure now is slightly greater than the induced fracture pressure. Okay, once your pump is off, so formation fluids will back again as we lose the effect of an APL. So let's back again here. When bottom hole pressure is slightly greater than the fracture opening pressure due to the effect of an annular fracture loss, APL, losses while pump on and gain when pump is off, return decrease with time, pit gain amount equal mud loss. So first action is to shut in the well, check pressure. You're gonna find shut in drill pipe equal shut in casing. So you need to bleed 50 by 50 from drill pipe and casing. If there is if no pressure build up, so that's ballooning, and you need to circulate bottom up through the choke, because if there is a small amount of gas to be out from the well, not to reduce the hydrostatic pressure. If there is pressure build up again, so this is a kick, you need to prepare to kill the well. That's for formation ballooning. Now to talk about something called kick tolerance. What is the kick tolerance? Simply, kick tolerance is the maximum amount of gas. Maximum amount of gas you can take as a kick, okay, and circulate it out successfully from the well without fracturing the formation. Again, kick tolerance, simply maximum amount of the kick, maximum volume of kick. You can successfully take it as a kick and circulate it out from the well without fracturing the formation at the weak spot. Here, kick tolerance is the maximum volume of a kick for a given kick intensity. at a given test that can be successfully shot in and circulated without exceeding the weakest point fracture pressure. So what is the kick intensity for a given kick intensity? What is the kick intensity? Kick intensity is the difference between the maximum pull pressure and the planned mud weight. For example, if our formation pressure equivalent to, let's say, 10 ppg, so we're going to use hydrostatic pressure equivalent to, let's say, 11 ppg. Okay. The maximum expected pull pressure, or the abnormal pull pressure we may face is about, let's say, 14 ppg. Okay, so now kick intensity is the difference between the maximum pull pressure, the abnormal pressure we may face, and the planned mud weight. Okay, so now the difference is 3 ppg. Okay, once the kick intensity increased, the kick volume will decrease as long as the difference between the maximum pull pressure and the hydrostatic pressure is increased. So the kick volume you can take and circulate decrease. Once the difference between the maximum pull pressure and the hydrostatic decreased, okay, so your kick volume will be increased. We're gonna see descriptive figure here. If you look here, kick intensity, difference between maximum pull pressure and the planned mud weight, and here is the kick volumes in parallel. Okay, so it is a reverse circulation, inverse relationship. If you look here, once we have 0.1 difference between maximum pull pressure and hydrostatic pressure, so you can take about 17 parallel as a kick circulated successfully without fracturing the formation. But if the difference is large, like 0.7, for example, so you only here have about 4 parallel to circulate. Okay, so the relation is not direct; it is reverse relationship. Okay, once kick intensity increased, kick volume decreased. Okay.
Sorry, this graph is applicable for any well or what? Or just example?
Not any well. Every well has a specific kick tolerance depending on some parameters like permeability, like planned mud weight, like hydrostatic pressure.
TVD. And something.
Yeah. There is some parameters affecting the situation. Okay. Now to talk about top hole or shallow top hole formation. While drilling top hole formation, there is a problem. A very dangerous shallow gas problem. Why shallow gas is very big problem and very hazardous? Because no POP to control the situation. Okay, only to have the diverter to direct the fluid away from the leg. No POP to contain the fluid or to contain the pressure from the well. So there is a good practicing to deal with the top hole formation. First thing is to drill a pilot hole, starting with a small diameter, then reaming and increasing the diameter. Use diverter all the time to divert any gas or any influx away from the rig. Control the rate of penetration to minimize the cutting, as the cutting may act as increase in the mud weight, so it may cause fracturing to the formation. So here, control rate of penetration to minimize the cutting in the hole. Use viscous sweeps instead of weighted belts. Use high circulation rate during diverting the gas. And use float in the string to prevent any backflow. Pump out of the hole, okay, all the time. Pump out of the hole. Here, for talking about gas hydrates is something like ice molecules or solid molecules may be formed in the flow line, cause the plugging for the flow line, so fluid can be able to pass to the second side. Okay, so gas hydrates only be formed in presence of these parameters together: relatively high pressure, relatively low temperature, water, and hydrocarbon gas. If we make ignoring or elimination for any of these parameters, so no gas hydrates can be formed. Okay, so let's talk if we have gas hydrates formed already. So to solve this problem, reduce pressure if possible, as it is formed in high pressure. So once reduce pressure, you eliminate the high pressure element. Raise temperature, as it is formed in low temperature. So once raising temperature, you eliminate the low temperature factor. If it is already formed, you can use injection like methanol or glycol or salt water to remove this hydrates. Okay. For most surface well intervention pressure control equipment testing, using a ratio of methanol or glycol, okay, to prevent gas hydrate formation while making pressure test. My last thing here for the PMP is drills, brake safety drills for training. Okay, so we have different drills: pit drill, trap drill, choke drill, diverter, and POP. All of these drills is to ensure the crew is able to effectively recognize and deal with different situations and react to the kick properly. For example, drilling or tripping drill, okay, you simulate as you have influx and you need to get the response of the crew, okay? So you await to see the response of the crew before shutting the well completely, okay? You make them know we are in drill, okay? So it's okay. We can go ahead and resume our operation, okay? So, for example, here we have diverter drill to ensure that the crew can divert the gas away from the rig successfully. Also, we have here choke drill to understand how the choke reacted during kill operation, how to open, how to close, how to take reading of casing pressure and drill pipe pressure, what is the function of lagging time, how much lagging time we have, okay? So that's all for drills and the training being conducted in the oil field or the rig side. And now, guys, we just finished our first part, PMP, principle and procedures. Any question at this part?
Yeah, one question, please.
Okay.
Earlier in weight on weight method,
okay.
The last case you told us that if there is a shutting drill pipe pressure 0 and shutting casing pressure 100 psi. You told that there is two cases. The one if we didn't reset the strokes. The second one what?
Okay. Yeah. I mean there is two reasons for yeah, two reasons, but both of them related to that the kill mud not reaching to the surface. One is you didn't make the 0 for stroke counter. Second is, as you mentioned, if there is error in calculation or there is washout in the hole. So both of them is related to kill mud not reaching to the surface. Okay. Yeah, so it's dependent on the kill mud volume. So how to know? You can identify after pumping the drill pipe capacity like this. You can identify from this point. Once you reaching the drill pipe, okay, is a pit. Once kill mud reach to the pit, or you think you pumped the drill string volume, so you need to shut down pump. Once you shut down pump, you're gonna find 0. Look here. Yeah, till this stage. Once you think you pumped 1812 stroke, okay, you need to make flow check. Stop pumping and check for pressures. If you're gonna find here 0 on the drill pipe gauge, so it's okay. Okay, you are okay. But if you found here still there is a pressure, for example, 100 psi or something like this, so you didn't take surface volume into your consideration, or your kill mud is not sufficient enough. Okay, your kill mud is not sufficient enough.
But if kill mud is not sufficient enough, so even the casing pressure inside the pipe pressure will increase, no?
Will increase, yes, will increase. I mean here we still have 100 psi.
No, I mean drill pipe. In the drill pipe also, if the mud is not sufficient, so the drill pipe will increase also, will not get 0.
Yes, I write here 100 psi, 100 psi. Once we thought we pumping the drill string capacity. Okay, if we found 100 psi, this may be two reasons. we may not make re-zero for strokes once the surface line has been bumped, or kill mud is not sufficient enough. Okay, so how to check is to complete pumping another 100 stroke surface line volume. If pumping 100 stroke or small or a little bit larger, then you found zero here on the drill pipe, so kill mud is okay, and you ignore the surface line volume. But if it's still pressure on the drill pipe, so your kill mud is not sufficient, and you need to prepare proper kill mud, then resume your operation.
Okay.
Okay, so any problem else before finishing?
Also about the gas hydrate, this hydrates. This one will face it in the open hole or in the
flow lines only.
Lines.
Yeah. For example, at a choke line, okay, for the flow lines.
Mm-hmm.
Okay, so any problem else for BMP?
I would like to ask how to calculate or determine the killing rate.
How to calculate the kill rate?
The kill rate. Killing speed.
Yeah, kill rate will not be calculated. Kill rate will be given. If you just remember for SCCR pressures, SCCR pressure is just like kill rate. For example, let me back again. Here, SCCR pressure, SCCR, yeah, here SCCR pressure. Why to record it, or what is the purpose of an SCCR? Here's this one. SCCR pressure is the kill rate, only recorded circulating pump rate, okay, slow rate, only used while circulating out a kick. So just to remind you, we just mentioned for SCCR pressure, we have two pumps, pump number 1, pump number 2. We need to take slow rates, okay, as we didn't circulate the influx with high rate. So at 30 SPM, for example, and 40 SPM. At 30 SPM, we need to record the pressure from pump number 1 from remote choke, and for example, 200, and here at 40 SPM, 300. Then shut down pump number 1, go ahead with pump number 2, same, 200, 300, okay? So we have two pumps with the same efficiency. One pump is backup for the second. We have here two rates. The two rates, because if we're gonna use, for example, 40 SPM, and we found that the mud gas separator can't handle the amount of the gas. So we need to shut in the well, secure the well, and go ahead with the second rate, with the slow rate, okay? So now the mud gas separator can handle the amount of the gas inside it. So kill rate not be calculated. Kill rate is a given, and have a pressure, pump pressure used as SCCR pressure or dynamic pressure you use for calculating ICP and RCP. Okay?
Okay, so we can say it's like by experience.
No, not by experience. You take it, actually, you run pump number 1, run actually pump number 1 during drilling operation, okay, at 30 SPM, and wait for the drill pipe pressure till stabilized and record that, okay, not by experience, actually. Then raise the pump rate at 40 SPM, 5 by 5, okay, and record another drill pipe pressure. Then shut down pump number 1 actually also, and run pump number 2 at 30 SPM, record the pressure. Then raise 40 SPM and record the pressure. So it is not by experience. You need to record it actually, okay? Every cases, like here, when to record the SCCR at the beginning of every shift, okay? Once shift has been ended and another shift has to come, you need to record. Start pump number 1, 30 SPM, 40 SPM, record for 2 pumps. If there is mud properties changed, bed nozzle changed, PHA, or if you drill more than 500 feet, so you need to record a new SCCR pressure. Okay, So it is
Yes,
not.
yes, no, about the pressure, I am clear, but my question was about the rate.
Yeah,
You
okay,
choose 30 or 40
okay.
by default, those
Okay.
should be 30 and
Okay,
40.
okay. We need to record that between 20 and 50 SPM. Yeah, by experience. This rates by experience, 20 and 50 SPM, yes.
Great, it was.
Okay.
Thank you very much.
Okay, you're welcome. Another, yeah.
Yeah, so if we are circulating any influx and the influx stay in the open hole,
Yeah.
and we saw that we may reach the mass.
Yeah.
So what we have to do?
We still in the open hole.
Yeah.
Okay, you have many options. First thing is to open the choke more. Okay.
Like this will get another influx, no?
No problem, but not to frag the formation.
So how we can kill the well?
How to kill the well by complete circulation, or make another circulation. If you use the Driller method, for example, and you are in the first circulation, okay, no problem to take further influx. Then you're gonna have some time, additional time, to circulate this influx out from the well. Another option is to secure the well, shut in the well, okay, and use slow rate. For example, if you kill with 40 SPM or 30 SPM, use low rate, 20 SPM, for example.
No, but this 20 SPM will increase because I saw that there is no, they are not taking consideration the friction loss. So if we're reducing the flow.
No, if for example, if you use 30 SPM, okay, so you're gonna find your casing pressure at this rate, for example, 700, and your mass is about, let's say, 850. Okay, so now you need, or approaching from 800, and you have only about 50 psi to reach the mass. So once decreasing here to 20 SPM, your casing pressure directly decreasing, instead of 800 to be, for example, 750. So the margin has been increased about 100 psi. Okay. Another thing you make, as mentioned, is to open the casing somehow. No problem. You have two dangers: to have further influx, frag the formation. Which one you prefer, frag or take further influx?
But let me tell you something, because while you are reaching the mass, because we have a big influx.
Yeah.
So if we get another influx, how we can control it later?
Yes, okay, I got your point, but that's a bad practicing. That's bad practicing. Let me remind you by this slide. Yeah, there is bad practicing may lead to exceeding the mass. All of these situations, you may exceed the mass and fracture the formation. So fracturing the formation is an option if you have bad practicing, not to shut in the well quickly, so you have larger kick size, so you can frag the formation. If you have bad practicing, for example, closing the choke more and more while pumping, okay, so your fracture. If you didn't open the choke or open the HCR, okay, while pumping, so your fracture the formation. During simulator, okay, if you as a supervisor frag the formation at any time, you will have immediate failure. So fracturing the formation is an option, okay? I not tell you all the time you can control the situation. No, sometimes you may fracture the formation. Okay? So once following the proper instruction, you will not reach the mass, and your eyes all the time between casing and mass, so it's okay. But if you did stupid action, sorry, I not mean you. If the one who are on the, for example, on the pump, on the POB, on the choke, have stupid action or bad action, okay, it's called bad practicing, like this one, bad practicing, okay. So he may make bad practicing lead to a big problem, okay. So the result will fracture the formation, okay.
Okay.
Okay, so any question else? Any question else regarding this point? Hey guys.
No.
Okay, so let's finish this one.